Hello and welcome to the Computer Vision Festival, hosted by the AI Accelerator Institute, a global community of over 400,000 AI leaders and practitioners, all striving towards one shared goal: inspiring the next generation of machine intelligence. With expert presentations on the festival agenda covering everything from space exploration on Mars to self-supervised learning, you're in for a treat. If you have any questions for our speakers or want to connect with them further, then ask away in the comment sections of the video and hear them answered at the end of each session in our live Q&As. If throughout the day you're loving the content, then be sure to check out the AI membership plans, where you can get access to exclusive content in the form of interviews, reports and articles. Access all areas passes to all past and future events. You can also join our Slack community, which is home to more than 2,500 fellow AI, machine learning and computer vision professionals, and is full of dynamic conversations and contributions. So if you're not already a member, come and join us today. Sign up using the link on the AI Accelerator Institute website. I want to say a massive thank you to all of our sponsors and partners for helping us to bring the festival to your screens today. Our amazing speakers for contributing some awesome content, and to you, our attendees, for joining us today. That's it from us, so go ahead, sit back, relax, and enjoy the festival. Okay then, so we'll just wait a few seconds until everyone is in the room. Really looking forward to this next session. So it seems that most people are filtering through as we speak. Okay, cool. So why don't we go ahead and kick this off. So welcome everyone to the next session of the Computer Vision Festival. Thank you so much for tuning in today. Super excited about this session that we've got coming up with John Curley, Senior Director of Product Management from Qualcomm. And he is here today to speak to you about advancing the future of industries with Qualcomm Cloud. And on that note, John, I'll leave it over to you.
Great, thanks, Jordan. Hello, everyone. Good morning, good afternoon, good evening, wherever you are out there in the virtual world. As Jordan noted, my name is John Curley, and I lead the product team here at Qualcomm in what we call the Cloud Edge AI organization. Ultimately, I'm responsible for hardware, software, benchmarking, and a number of other areas, anything involved around our products in this specific space. I'm honored to be here today at the Computer Vision Festival, representing Qualcomm, sharing some exciting work that we're doing around the Cloud AI 100, which is our first generation AI inference accelerator. This is my first time joining the conference. I'm excited to be a part of this event, and I wanted to thank Jordan for offering me this amazing opportunity. And speaking of Jordan, I'm sure there's a timer going, so let's get right into it. I think there's about 24 or 25 slides and about the equivalent time to work through them. Okay, so first, a little bit more about Qualcomm. So for those that don't know, Qualcomm's been around for 36 years next month in July. It was founded by Irwin Jacobs and 6 others here in San Diego, which we are still headquartered today. From the start back in 1985 through today, our focus has been around connectivity. And although the underlying technology has changed from CDMA and 5G today, what hasn't changed is our overall strategy and focus around investing in technologies that enable worldwide to connect and to be connected. Our efforts around artificial intelligence, AI, are well aligned to that initial vision our founders shared. At Qualcomm, we invent breakthrough technologies that transform how the world connects, computes, and communicates. As I mentioned, for almost 36 years, we have been a tech leader in this space. Initially, we led the mobile industry into the digital age. If you can recall that device to the far left of your screen here, for those who've been around a long time, not too long ago, it seems like to me, but then we connected smartphones to the internet. We put mobile computer essentially in our pockets and unlocking whole new capabilities and industries. And then today with 5G, we're really taking this innovation to virtually every other industry, which I'll touch upon today in my talk focused around AI and computer vision. Leveraging this mobile technology, we're enabling new experience through what we call distributed intelligence. I know my colleague Vinesh, also here at Qualcomm, will be speaking more about this tomorrow, so I don't want to steal too much of his thunder. But essentially, distributed intelligence is marrying the fast and super secure mobile AI processing on your device, which I'll touch upon later. A lot of our history has been on-device AI, and connecting that with the powerful AI capabilities of the cloud through high-speed, ultra-low latency 5G connection, enabling new use cases that we've never seen before. Through this 5G connectivity and leveraging our mobile DNA, or low-power processing DNA as well, we're bringing cloud and the edge closer to the consumers, delivering new user experiences, seamlessly working with our industry partners. Okay, so you might not know this, but Qualcomm has been working on AI for over 2 decades. I know it might seem kind of wild. This is before AI was exciting and popular as today. But we've been thought leaders in this space for many generations, successful AI commercial products in the market for many, many years as well. In the interest of time, I won't go too deep on this slide, and there's a lot more data points in history that are not captured here. But we've historically been focused on the mobile space from a facial recognition perspective, voice assistance perspective, real-time translation, launching over 6 generations of AI-enabled devices in the market. Generations are multi-year generations. With the Cloud AI 100, we're leveraging much of that knowledge into what we're doing today on the cloud and edge markets focused on low power processing and AI. So what does this all mean? So historically, what this slide demonstrates is how we've addressed this amazing opportunity on AI from, I'll say, the sub 30 TOPS perspective. TOPS, again, trillion operations per second. So again, this is kind of a historical slide. On the lower side of this chart, in the bottom left corner, this is what we call our QSC product line. This addresses opportunities such as smart speakers, smart cameras, sensors, really leveraging our digital signal processing, or DSP technology. As you move up and to the right, we scale from 3 TOPS to 30 TOPS. You're getting more into opportunities from classic mobile, what we call Snapdragon, XR, which is AR and VR, automobile offerings as well, which has been a great success story to Qualcomm around in-vehicle infotainments, Windows on Snapdragon, which is our effort into the PC space as well. So a lot of solutions that span many markets already historically. So how do we build from there, right? So with the introduction of the Cloud AI 100, back in April 2019, we're now enabling new opportunities on the high end of the AI inference market, which some leading analysts are forecasting, like Omnida, for explosive growth on, which I'll touch upon in a little bit. As you can kind of see on the top end of this graph on the right-hand side, we have a robust set of offerings across different use cases on the Cloud AI 100 side. So we have 3 discrete offerings. I'll get into it in the slides coming up. But basically, we have a greater than 50 TOPS solution, we have a 200 TOPS solution, and a 400 TOPS solution. On the edge side, we've optimized this, what we call dual M.2E, for this market that addresses performance in the 50 TOPS space and above, around 15 watt TDP. And we have a compelling form factor and low power AI leadership that really makes it a great fit for applications like this. The dual M.2 is a standard OCP form factor. I'll touch upon that soon. It's a 46 millimeter by 110 millimeter, optimized for the data center and hyperscaler. It's a best-in-class performance from this card, targeted for data center applications. And then up to the right, we have PCIe. This is your standard kind of half height, half length, 75 watt card that is addressing up to 400 TOPS, in a 75 watt card thermal design TDP perspective. So really compelling solutions in scaling up our performance leadership around AI. So this kind of gives you an idea of why we're excited on this space. This is not John's view of the world. This is outsiders' perspectives on how big the market is. And external analysts are forecasting really explosive growth, especially in the AI inference market, which is where we're focused on today. And we're on the front line seeing this, right? So we're working closely with customers and partners and bringing compelling solutions to market. So this report is a recent report from Omnida that shows explosive growth in AI, especially around inference, which is dominating the market today, as you see, based on their forecast. As we've seen, past, the forecast really continues to grow, and we're really excited to be on the forefront of this exciting growth. This table is kind of at a higher level. Doesn't really align with the slide I talked about earlier around, greater than 50 tops or something like that. But if you kind of peel it back, you would see the opportunity, especially in what they call the high segment, as being really where the growth is and where our Cloud AI 100 shines. So getting a little bit more into the products. I'm a product guy, so I like to talk about products. So I'll touch upon real quick on the markets that we see, then we'll get more into the product side. So from a market landscape, what we see, there's a number of emerging opportunities that our family of AI accelerators address beyond, again, the traditional mobile or IoT or PC, as I touched upon. Really kind of focus on three very interesting and compelling markets, and we're seeing very consistent and clear opportunities here. The market requirements going to change customer to customer, different solutions. I quickly touched upon the card types, and I'll get into that later. Security, power, software, but we view it as really a family of opportunities here. First and foremost, on the data center, cloud edge, kind of going top to bottom on this slide. A lot of cloud service providers, hyperscalers, a lot of opportunities here around natural language processing, NLP, recommendation type networks, seeing a lot of opportunities there. 5G edge box, everyone's kind of got their name for this, right? Intelligent edge or edge gateways or whatever it might be. This on-premise embedded standalone device, we're seeing a lot of object detection and classification. The deployment could be light poles, enterprises, retail, whatnot. And this is a really compelling solution and opportunity we're seeing today, not only for our Cloud AI 100, but also for our 5G technology and our AP technology as well. And then on the 5G infrastructure side, this is an area that I'm particularly excited about. We're seeing a lot of classic kind of equipment providers taking traditional computational intensive beamforming algorithms as an example and replacing it with new neural net algorithms. So this is an area that we're helping to change the industry. Okay, so let's get into a little bit more about the product. Okay, so delivering this industry-leading performance, we offer three different AI accelerator cards. From more the standard half-height, half-length solution on the left-hand side of this chart, mostly targeted at hyperscaler markets, data center, to two different dual M.2 edge cards that are aligned with OCP, Open Compute. So if you're familiar with that terminology. The Open Compute, dual M.2 solutions might be better suited for on-premise edge solutions like the one on the far right. We configure each solution with appropriate amounts of DRAM our customers are requesting, and our dual M.2 card is in the middle of our highest performing tops per watt. So this card in the middle. Uh-oh, I heard I froze. Can you hear me?
I can hear you fine on my end, John.
Okay.
Nothing's frozen. Audio seems fine.
Okay, I am on the side that I froze. So, okay, I'll keep going. So Jordan, hit me up if there's network issues. I'll kind of get into each of these solutions. So, each of these accelerators has a very high level of on-chip SRAM, approximately 9 megabyte per AI hardware block. So each of these have different configures of embedded AI hardware blocks. This allows us not to go out to the LPDDR quite as much, even though we use, in these cases, LPDDR4X. This helps drive higher performance per watt and lower costs for our customer rather than using other solutions like HBM or GDDR as an example. We do have very high memory bandwidth when needed, and we can configure DRAM density solutions as well. Any of these cards from 8 gigabyte up to 32 gigabyte. The different configurations that are shown here in each of the cards are driven by customer needs and requests that we see. So we're very focused around performance needs of various card TDPs, thermal design power, right? We know card TDPs drive many form factors and not the chip as well. Okay, I'm getting an IM that, okay. So we also support PCIe Gen 4 out to the host. So again, these are offload engines. These are accelerators. So they pair up to a host processor. It could be a server CPU, could be mobile CPUs, whatever it might be. And so we do support Gen 4 by 8 on our PCIe and dual M.2 card. And then on the far right side, we did go down to by 4 PCIe Gen 3 for our embedded solutions. We went to Gen 3 to meet kind of industrial requirements, temperature for outdoor deployments. We could also support Gen 4 there as well. So we just optimized that solution. So, and not specifically called out here, but we can support multi-card solutions. We can improve performance with card-to-card communications through PCIe switch without going through the host solution for large networks. Could be recommendation networks as well, which I talked about. So again, three key solutions that we're driving today, and all of those are in customers' hands and sampling today. Okay, so as I mentioned earlier, one of the really exciting opportunities that we see in space is what we call the 5G Edge Box. This is just a picture, and I'll get into a little bit more, of our solution that we've been providing since October of last year. It's a development kit, but it kind of gets customers started on the solution if they're interested. So this kind of explains it a little bit more. So 5G Edge Box, we really view this as really a greenfield opportunity that we're excited about, and that can really benefit Qualcomm's comprehensive solution. So although near and dear to my heart is the Cloud AI 100, we also have leading technology around AP, application processor, like the Snapdragon 865, and our 5G solution as well. So in order to drive this market, we introduced this platform again last year. It's in customers' hands, but it's really a development tool specifically tailored to, and driven for Qualcomm to design and get customers started who are considering opportunities in this space. And we are working with a number of partners to drive more turnkey commercial solutions in the future. So stay tuned on that front. But this is the development kit that we've been sampling now for about 8 months and giving customers' hands. So again, really compelling solution. Snapdragon 865 can decode 24 streams of full HD in a really thermal stringent, mobile-like form factor, and then 5G connection as well is there too. Okay, so use cases. I wanted to hit upon a couple of use cases. I could talk about this for days, but just in the interest of time, and I want to give time for Q&A as well, we kind of picked 2 different edge use cases and 2 different data center use cases. They're not meant to be comprehensive by any means. It's just meant to, give you a little bit more insight on what we're seeing around Qualcomm for these experiences. And I'll go through these quickly. First, on the edge. So this is what I think of as really a classic kind of retail type of use case, right? Maybe this is a small grocery store or a pharmacy or something like that, where there's a high-level AI and computer vision run on-premise. So again, think back to that AI Edge box that I showed you before. This would be a great example that would fit in that. This particular use case can help, maybe prevent loss, right? Stealing. Operational efficiency, understanding when customers are waiting and they need support, or even safety through a classic kind of image classification network, maybe a ResNet 50. There's a tripping hazard there too, right? Identifying a bottle on the floor and alerting a store manager immediately to rectify the situation and potentially avoid an injury to a customer, a lawsuit, or whatnot. So this is here you have a lot of different cameras going. They're capturing a lot of different potential alerts in this particular case. And again, this is a great example where our Snapdragon 865, which has all of that video processing along with our AI, comes into play. And maybe you have a 5G connection on box too. Maybe if a customer slips and falls, you want to capture that image, you want to capture that video, maybe store it in a larger data center for further insurance reasons. So that's just an example that we see. Here's another example, kind of building off that. This is a use case we might all start to get reacquainted with, right? In airports. Maybe in the U.S., a lot of children are on summer vacation, and I see more and more that people are starting to travel again. So this might be a case that many can relate to. So similar to the last example, this is another on-premise use case with various alerts for vision-based networks, right? This could be object detection model, maybe putting a bounding box around an unattended suitcase. You can see there on the far right. Or an object tracking, following a person running through the airport. That could be a safety hazard as well, right? And tracking that. Or as a parent, for me, my kids are older now. I was talking to Jordan about this before we started. I have teenagers now, but an unattended child, right? Understanding that there's no one around this child and they might need help and attention as well. So I love to really focus on those real positive aspects of AI and around safety. So those are some examples there. Maybe transitioning a little bit more to cloud. And again, the line kind of blurs from our perspective between the two, but I'll quickly touch upon this. So, focusing maybe on social media. Here you see a number of exciting use cases from maybe natural language processing, right? Maybe a model like BERT, where you can converse with someone in real time who doesn't speak your language. And it'll feel very natural. And with no latency. Recommendation networks on items you might be interested in, based upon past experiences. Could be, visual from pictures you made, or even other past shopping experience, really tailoring that. That's a really powerful use case. Being a teenager, as I mentioned, teenage parent myself, I'm especially interested in the inappropriate content area, whether it be videos or images or whatever that's captured and addressed. Before getting posted through AI. So that's, I think, something that's very important to me personally on my level. And then, this is something I think we can all relate to as well. This is the last use case here around medical and AI. This is an example that shows an X-ray and identifies a potential area of concern. I don't know if you can see it very well, but that's what's the vision of this slide. And makes a recommendation maybe to medical staff based upon a trained model that might have been missed, that could impact lives, that can impact safety and our health. So this is something that we're seeing a lot of really exciting use case for as well. Okay, so I'll touch a little bit upon kind of our solutions, right? So you might be thinking, hey, John, this is great. I understand your product. I understand your use cases. I understand your markets. Why is your product compelling? Why is it interesting? Why should we pay attention to what Qualcomm is doing as well? So I want to go quickly through this. We recently submitted our ML perf numbers or ML commons numbers. We did 2 vision networks. We did a ResNet 50 and a ResNet 34 SSD submission. I want to quickly touch upon that if I can. So this is our first submission into MLPerf for the Cloud AI100. This was just done for MLPerf 1.0, and we're excited to be involved in this moving forward with 1.1 coming up in this August. So we submitted with models and form factors that we're seeing essentially strong customer interest and traction on. As I mentioned, ResNet 50 and ResNet 34 SSD are 2 that we submitted on. So not only do we submit 2 models, we also submitted multiple form factors, as I mentioned, form factors being those card types. So here we did this is a ResNet 50 example, right? Which is a convolutional neural net focused on image classification, as we all know. And just to kind of calibrate you on this slide, on your x-axis here, as you go left to right, power actually goes down. And on your y-axis, as you go bottom to top, your performance goes up. So just that's the way kind of how to read it. So here, really focus on performance, and we compared against industry-leading solutions in the market today from our friends at NVIDIA, as an example. So what you can see here is, as an example, if we start maybe on this x-axis, you can look at, roughly, a half-height, half-length card, 70 to 75 watts against, our solution versus a T4 solution. You can see that we're approximately 4 times better performance at this equivalent power level. So very, very compelling solution. T4 has been a great solution in the market, really industry leading, and kudos to NVIDIA for doing a great job there. Next generation solutions from NVIDIA, the A10 or A30, those were recently announced at GTC, and they submitted those last cycle as well. The power did go up. They more than doubled the card TDP. They went to more of a full height, full length card. But as you can see, performance for us at less than half the power is still industry leading as well. So, this is really looking at performance. In this case, again, ResNet 50, what they call offline performance is really peak performance. And that's a solution, that we're really excited about. We're seeing a lot of customers. This is, integer 8, batch size 8, for those that want to know all the details. And this is all public information as well. We didn't include other solutions, just like A100 as an example. Those are, 250 watt TDP card solutions, or A40, which is more than that, 300 watts, because they kind of fall outside the scale of this chart as well. So we try to compare apples to apples as well. So anyway, so yeah, some really exciting solutions here. I'm going to kind of quickly go through this. I can talk about this for days, but next one we did here is very similar setup as the last slide here, but here we looked at a large tensor. This is an SSD ResNet 34, which is, based off a COCO data set, right? So similar type of thing when as ResNet 50, you look on the left-hand side, you focus really on data center. The right-hand side, these are edge as well. On the left-hand side, I should note, MLPerf 1.0 just started with power submissions, which we did a power submission. And here what I did is I compared performance with publicly noted card TDP numbers. So these are not necessarily power submissions, but I just normalized it for card TDP number. And this also doesn't capture great things like batch sizes and all that good stuff. So we use batch size of 8, small batch size. Others can use higher batch sizes of 32 or whatnot. So that can drive different performance levels as well. So what you really see is our solution again is a fraction of the power and showing best in class performance per watt. And performance per watt, is in our DNA at Qualcomm. Really leveraging that technology from the mobile side and bringing it over into edge and data center, and it's resonating really, really well in the market, and really excited about the opportunities that we're seeing. So what does this all mean? So back in March, I think this is a really great example of how this performance per watt story really, really scales. Back in March, AMD announced their next generation EPYC, what they call Milan 7003 solution. As part of that announcement, a new Gigabyte G292 Z43 server solution was also announced. This server solution works very, very well with our PCIe card, as I mentioned, our half height, half length card, capable again of 400 tops in that form factor. And in this new 2U server, you can actually fit 16 of these Cloud AI 100 cards into that at 400 tops each. This means, cumulatively, you can deliver 6.4 petaops. That's 400 tops by 16 cards per server and 19 servers per rack, which we think is amazing performance that will unlock, new and exciting experiences that demonstrate how our low power performance can scale at the server and the rack level. So if I could tie this back to the previous slides, right, a little bit more context and aligned with our ResNet 50, this translates to more than 6 million images per second on one server rack for ResNet 50 example. And this kind of AI performance can surely enhance, extend, and scale AI experiences to the world. So this really provides, I think, for me, a real concrete example of how our low power performance scales at the server and rack level. So I want to finish on time, so let me, I think I'm looking here at the clock, I think I have 2 minutes or so. So let me wrap this up. So kind of key takeaways that I wanted to show everyone is, again, this might be a new area for Qualcomm, doing AI at the data center level and whatnot, but we're really leveraging a lot of heritage and history of the company, again, 36 years next month, our mobile DNA, our low power processing DNA, and over 2 decades of AI research and commercial products that we're bringing to market. And that's really, really makes us excited about that, really addressing this market in a different way from a performance per watt story, leveraging our mobile technology. This is driving significant traction today, and we're looking forward to sharing more exciting launches to come in the second half of this year. And we're very, very committed to the space. You kind of see MLPerf results. that's something, to be honest, that feedback I got middle of last year, where they say, hey, John, this looks really compelling, but we want to see your ML-Perf results. And if you look at ML-Perf, it's a lot of work. We're excited to be part of that. It's a really, really great forum to be part of. But it's a lot of work. And we took the risk and put our results out there. And not everyone in the industry is doing that. We're really excited to do that, and we continue to do that. So as I said, this performance per watt, and latency, leadership really translates to what our customers are expecting from us and where we're seeing the interest. So we're really excited about that. And thank you again for this opportunity to share a little bit more of what we're up to. And with that, I think I got 1 minute to spare, Jordan. So maybe a Q&A.
John, thank you so much. Wonderful, wonderful presentation there. Super insightful, super interesting. Always really cool to hear what major players such as Qualcomm are doing in the space. So yeah, can't thank you enough. Cool. Yeah, so we can open it up for Q&A now. So if you've got a question, feel free to pop it in the chat. We've got some time. We've got 10 minutes. So we'll definitely get round to it. So we can start with basically the first question that was posted, John, from our old friend Dale here, actually. So I'm not sure which part of the presentation this was referring to, but you may know yourself, John. So what are the tops/what? So let me post it back in the chat. So it's quite a simple question. It was just simply this. I'm not sure which part of the presentation he was referring to, but I did just read that in the comments there. Or Dale, maybe if you want to.
Okay, you're asking our tops per watt. Yeah, so there's really three kind of solutions, right? So at the highest end, these are, again, just to clarify, these are peak, int 8 tops, right? We get 400 tops in a 75 watt half height, half length type of card. And then moving, down the stack, if you will, what we call our dual M.2, 200 tops at around 25 watt card TDP. And these are all scalable. And then what we've done on what we call dual M.2E, or stands for edge or embedded or whatever, we are driving 70 tops at around 15 watts. So those are kind of the three solutions.
Perfect, thank you. I hope that answers your question, Dale. And then, so a question, next one would be, do you support TensorRT for inference performance support? Also, if you have built-in YOLO/TensorFlow available in the SDK. I'm going to post a question as well so you can read it to yourself, John.
Okay. Yeah, so we didn't get into the software too much, but we do provide a very open software solution supporting all major frameworks and vendor runtime. So OnyxRT, Glow, the major frameworks we support as well. So we do have a very, very open software model. PyTorch, TensorFlow, Caffe, MXNet, Caffe2, Onyx, etc. So I didn't get into it today. I'd love to follow up on those questions, but our software is meant to be very open, right, to very different models and frameworks and runtimes. That's kind of the vision. We also support Python for development and container, Dockers, Kubernetes, and different debug and monitoring tools. So it's hard to kind of be too succinct in this area, but yeah, there's not a focus of the presentation today, but very open-ended software.
Okay, cool. And then just another type like curiosity question from the same person, which is how do you train a model with an unattended child? Do you use LSTM or just CNN or transfers attention?
We don't do training today, right? So we're an inference accelerator, right? So we'll leave that up to the different training solutions to figure out how to train a model. There's lots of different parameters and things they can do there for sure. But we're very much focused today on inference. But moving forward, stay tuned on things like federated learning and training where we'll go in the future.
Cool. Thanks, John. And then, another general type question from Max. So it was, how do you think regulations are going to impact machine vision? And then he did actually post a link for everyone to jump onto. But what's your thoughts on that, John?
How do I? I don't want to lean too far forward on this, right? I'll leave it up to the regulators. But we focus on the good that AI brings, right? We're excited about the capabilities that come to market with it, and I like to focus on the use cases that really I think help better society, right? Whether it be as I mentioned several times, editing inappropriate content. I think that's going to be a real popular thing with social media and whatnot. To public safety and whatnot. So, it's, I'll leave that up to the regulators to figure out how they want to manage this moving forward.
Okay, cool. Thanks, John. Moving on, a question from Jay Sill. So how would this be used for telesurgery?
How would this be used for Yeah, I guess, are you referring to the use case, the medical use case?
Yeah, I think so. I think that comes towards the end of your session, John.
Yeah. I'll leave that up to them. I'm not in telesurgery business, but here the example, I think they were talking about this example right here, if I'm not mistaken, right? So this is, we're seeing a lot of, interesting opportunities in the medical space. And so this is just one example, but telesurgery and AI, we'll see. It's not my area of expertise. So we'll see what comes.
Cool. So yeah, I've just got a private question from someone, John. So just a bit more of another like curiosity type question. And it's from Wendy. So it's just curious about the biggest challenges moving forward in this industry. As Qualcomm, you've got such a broad scope within AI.
Yeah, I'll be very transparent. I think what Qualcomm does really well is low power processing and leveraging that technology. I think it's the software, right? I think it's insatiable demand, new models, bigger models, running, especially recommendation networks and whatnot. So it's the software side. I think, quite frankly, is how do we support those customers, and how do we support new use cases and experiences. And I think moving forward, models are going to get much larger. Complexity is going to get much more difficult. And how do we make it really compelling and interesting and easy to use and work on our hardware? And I'll give NVIDIA lots of credit. I mean, their CUDA software is phenomenal. They've done a great job, and they've been at it for a long time. And how do we make it just as easy as it is for NVIDIA? So I think the software side is going to be a challenge, but we're really excited about how our approach to the software and where it's come and where it's going.
Cool. Yeah, super exciting. And that's about it for the questions. We've got 3 more minutes or so. So if you do have a question, feel free just to chuck it in the comment box there. But yeah, once again, John, really enjoyed that. Seems like the audience did too. And yeah, you're welcome back as a presenter anytime.
All right. Hey, thank you so much. I look forward to that. And, for others, feel free, reach out with any other questions you want to hit me up on. I got quite a few LinkedIn requests today. So I appreciate all those connections. And we're really excited to share more of what we're doing. And stay tuned. We're going to share much more about what we've been up to in the second half of this year. And we're excited to continue to be part of this.
Cool. Thank you so much, John.
Thanks so much.
We'll be hearing from you soon. Take care.
All right. Take care. Bye-bye.